What about the exponential function f of x equals 3 to the negative x power? What is that graph going to look like? And one thing I can do is I can rewrite this. I have a negative exponent here, so I can view this as the same thing as 1 over 3 to the x power. It's just using my property of negative exponents and how I deal with those, and realize that I could put that exponent on my numerator. 1 to the x power, 1 to any power is still just 1. And then I can use another property of exponents and basically say that when I work out 3 to the negative x, it's going to be the same thing as working out 1/3 to the x power. So f of x equals 1/3 to the x power, or f of x equals 3 to the negative x. Those are the same exact function. All right, so let's go through and make our table of values here. We'll start with the easiest ones with 1. 1/3 to the first power would be 1/3. 3 to the negative first power is still 1/3. So I'm going to go right 1 up 1/3, about right there. With an input of 2, 1/3 to the second power. 1/3 times 1/3 would be a ninth. That's exactly what I get if I plug 2 into this. 3 to the negative second power is still a ninth. So here I am about right there. And with 3, 1/3 to the third power, a third times a third times a third would be 1 over 27. So now I'm even closer to my x-axis here, even closer to 0. Anytime 0 is an exponent, my output is going to be 1. 1/3 to the 0th power is 1, with of course one exception. 0 to the 0th power is undefined, but other than that, if 0 is your exponent, your output is 1. -1 here. All right, so the easiest way to look at this would actually be to use this one. 3 raised to the opposite of -1. So my x value is -1. So really I have the opposite of -1 here. Opposite of -1 is +1. 3 to the first power would be 3. And if you're working with this one, 1/3 to the negative first, you can think of this as distributing this -1, 1 to the negative first, 3 to the negative first, rewriting it 3 to the positive first over 1 to the first, and you'll still get that 3 there. So the quick way is, of course, to take the reciprocal. 1/3 to the negative first power is the same thing as 3 to the positive first power. So input of -1, output of 3. -2. So 1/3 to the negative second power would be the same thing as 3 squared, or 9. And notice plugging that -2 into here, same idea. Opposite of -2 is +2. 3 squared is 9. So -2, 9. And the last one here, -4, would give you an output of 81. I'm not going to be able to graph that. All right, I'm going to do my best to draw a curve that, let's try again. Still learning how to kind of get this. It's a little bit difficult to draw with this graphing tablet, but I'm getting better at it. All right, so rough sketch, something like that. Notice this is different than our previous example. Let's go back to our previous. This was 3 to the x power. That was exponential growth. And this is exponential decay. Notice how quickly this thing has fallen. Just like the previous problem, let's take a look at domain, range, intercept, asymptote, increasing, decreasing, and continuous. So the domain, just like before, I can plug in whatever I want. Positives, negatives, decimals, fractions, it's all real numbers. My range, I never have a y value that is 0 or below. This graph is basically kind of hitting a wall here and just getting closer and closer to 0. So my range is going to be all positive real numbers, or everything from 0 to infinity. My intercept. Now, I must have skipped plotting that point there, that 0, 1. So my intercept should be right here at 0, 1. So let's fix that up. And let's fix up this part of the graph. So I should be going more like, okay, something like that. I think I made it worse. Hopefully you get the idea here that this is going to go through the point 0, comma 1. So I do have this intercept at 0, comma 1. It's my y-intercept. Asymptote, only one. It's a horizontal asymptote, and it is at y equals 0. There is no vertical asymptote. This is always going to keep moving, although increasing very rapidly. There is an output for -3 and -4 and -5 and so on, but you're going to get closer and closer to 0 over this way. Is it increasing or decreasing? Well, my y values are dropping. This is decreasing. And it is definitely a continuous function. You can draw this without lifting up your pencil. Once again, excuse my graph, but hopefully that all made sense. One more thing that I want to point out is that when we did our graph of f of x equals 3 to the x power, remember that we had something that kind of looked something like that as a very rough sketch. And the one thing I want to point out here is that this graph, this 3 to the negative x, if you remember your transformation stuff, if this is my original function, f of x equals 3 to the x, and if I evaluate that function at negative x, that would be 3 to the negative x. And f of negative x is when you're going to have a reflection in the y-axis. And that's exactly what happened. This was my 3 to the x power. If you take all the points and reflect them over the y-axis, you're going to get this graph right here, which is 3 to the negative x power.